Within subject design, a single group of subjects is exposed to all levels of independent variable, keep individual differences constant, and the simplest form is pre and post study. There are carryover effects, so you need to be careful of. Previous exposure can affect performance of subsequent treatments. Between subject design, different groups of subjects are randomly assigned to the levels of your independent variable. A single factor randomized group there are two groups, and one has to be experimental, the other one has to be control. Multi-group design, there are additional levels of independent variable. Parametric design is independent variable levels represent quantitative differences, and non-parametric design is independent variables levels represent qualitative differences. When to use within versus between. A within subject design may be best when their individual differences are large. It is important to economize on participants or subjects, or you want to assess the effects of increasing exposure on behavior. Sources of carryover. There are three sources: learning/practicing. Learning a task in the first treatment may affect performance in the second. The second is fatigue. Fatigue from earlier treatments may affect performance in the latter treatments. The third is habitual sensation or sensitization. So repeated exposure to a stimulus may lead to unresponsiveness to a stimulus, or exposure to a stimulus may lead to subject respond more strongly to another. Dealing with carryover effects. Minimize by pre-training or practice testing or resting between treatments. Or you can make the treatment order an independent variable. So you can find insights into it later or future studies. Counterbalancing. The various treatments are presented in a different order for different subjects. The Latin square design. That when used, you make the number of treatment orders equal to the number of treatments. So each treatment appears exactly once in each of the rows and columns. Matching. Match group designs are used when you know that some variable correlates with a dependent variable. P's matched on the variable before being studied. So something like intelligence. So you group the intelligence people together. The P's matched on the variable before being studied. So underneath that is the matched pairs design or the matched multi-group design. So what you do is you obtain a sample of subjects, measure the subjects for a certain characteristic, such as intelligence, that you feel may relate to the dependent variable. Then you match the subjects according to the characteristics. So pair subjects with similar intelligence scores to form pairs of similar subjects. So you just group all the people with the same intelligence scores. Then randomly assign one subject from each pair of subjects to the control group and the other to experimental group. Then you carry out the experiment in the same manner as a randomized group experiment. Factorial design. Why factorial designs? Well, effects of combinations of variables. It tests the effects of combinations of variables and the interactions of variables. So factorial nomenclature is a 2x2 or 3x3x2, which means the number of numbers and the number of factors, or the value of a number and the number of levels, or multiplying number of conditions or cells in design. Factorial designs can be useful to discern main effects in interactions. What is main effects? Main effects is manipulating one of the independent variables produces a change in the dependent variable. So in a 2x2 design, you can have 0, 1, or 2 main effects. Now, interactions. Interactions is the effect of one independent variable on the dependent variable is dependent on the other independent variable. Interactions can be extremely interesting for they tell us that the effects of one variable depend upon another. Higher order factorial designs. More than 2 independent variables are included in a higher order factorial design. As factors are added, the complexity of the experimental design increases. The number of possibility of main effects and interactions increases. The number of subjects required increases. The volume of materials and amount and time needed to complete the experiment increases. Question wording effects. Wording of a question can change how participants respond due to implications. Different judgments, even though they objectively equalitative information. Equivalent. Types of framing effects. Attribute, there are 3 framing effects types: attribute, goal, and risky. So attribute, it would be the 80% lean, 20% fat. So people's evaluations are more favorable if the key attribute is framed in a positive rather than negative. The goal to eliminate red meat. People are more motivated to avoid a loss than achieve a gain of the same magnitude. And the risky choice. So high level cholesterol, there are 2 programs. People are more risk-taking with a negatively framed outcome and more risk-averse with a positively framed outcome. Mixed design includes a between subject and within subject factor in the same design. Allows you to evaluate the effects of variables that cannot be manipulated effectively within subject's design. Complex mixed designs would include more than 2 factors with any combination of between subjects and within subject factors. Why use a mixed design? Well, 3 reasons. It's stronger than purely within subject design because it can lessen your error due to individual differences and can help to address carryover effects. Second is can help rule out threats of internal validity and such as history, malnutrition, testing, instrumentation, regression. And last, it can extend comparisons across conditions. Using a covariant. Including a covariant in experimental design. A covariant is a correlational variable, such as self-esteem or GPA, in experimental design. So covariant is a correlation variable in a experimental design. Subtracting out. The influence of a covariant reduces error variance. So it makes your design more sensitive to the effects of an independent variable. Quasi-experimental designs. A comparison of any intact group would be considered quasi-experimental at best. It does not give you causation, just correlation. Examples would be age, gender, time. There are 3 types of quasi-experimental designs. The first being time series design, which you make several observations of behavior before the baseline and after introducing the independent variable. Useful when behavior in question may be unstable. Interpreted time series design is the same as the second, and it's basically the same thing. You make several observations before and after but the difference is natural occurring event. So interpreted, natural occurring. Equivalent time sample design. Equivalent time sample design, which is third, is repeatedly introduce the treatment condition alternated with periods of observation without the treatment. Useful when effects are temporary. Developmental designs often are interested in studying change over time. Factors that may be confounded are age, how old are the participants, cohort, generational effects, time of assessment, when were they assessed. Those are 3: cohort, age, time of assessment, and then the cross-sectional design, which participants from different age groups are run through a study at the same time, creating cohort groups based on participants' ages. This allows you to collect developmental data in short periods of time and tells you about differences, not changes. The drawbacks. The cohort effect, which subjects of a given age are affected by factors unique to their generation, and different cohorts assessed at the same time, thus they are at different ages. May not be appropriate for studies using widely ranging age groups. What are the advantages and disadvantages of various developmental designs? The cross-sectional design, advantage is inexpensive. Disadvantage, there's no direct measure of age changes, just age differences. Difficult to establish equivalency of measures. Limitations of results to time of assessment. And confound age differences with cohort differences. Longitudinal design equals single group of participants measured several times over a period of time. Avoid generation effect. Advantage is a direct measure of age. Disadvantage, it's costly. Subjects loss or attrition results in non-representative / equivalent samples across time. Measures become obsolete. Repeated testing effects, so like carryover effects, and limitations to cohort assessed results. confounds age with time of testing. Time lag design, which is the third of types of developmental design after cross-sectional longitudinal design, time lag design. Same ages studied at different times show cohort effects, not age-related changes. Cohort subsequential design combines cross-sectional longitudinal component in the same design. So groups of different ages are first studied simultaneously and then studied again at 1+ later times to provide a longitudinal perspective. So CNA tests for not but generation effects, or can test for generation effects but not eliminate. Protecting participants before or after testing them, ethics, research relevant standards, types of single subject designs. Single subject designs, observations from one participant, no averaging, used to evaluate macro level effects on neighborhoods, communities, large systems, smaller systems like families, individuals. Frequently used in applied research than basic, involve repeatedly systematic measurement of dependent variable before, during, and after manipulation of independent variable. Advantages and disadvantages of single subject research. The advantage is rich set of data about particular behavior may be the only appropriate design for some solutions. Individual scores not masked by group averages. Makes identifying and controlling sources of error variance easy. May reveal subtle effects of an independent variable lost with a group approach, and the causal relationships can be established with very few subjects. The disadvantages of single subject research. Making multiple observations is time-consuming and can be tedious. The single subject approach is not appropriate for all research questions, such as jury decision-making. Results may be limited, generalizability. All variables that can cause error variance cannot be identified and controlled over biases. Now, single subject research phases and design conventions. Phases are distinct periods of time in which specific things happen. So no intervention phase, which is a baseline or withdrawal, are represented with a Roman letter A. Intervention phases are repeated by other letters B or C for additional factors. Phases are always separated by vertical lines, and there are breaks in the graph. The breaks in the line call attention to the discontinuity between conditions in adjacent phases.